So, hello everybody. Welcome to the first ever Yocto Project official live coding stream on Twitch, which is technically a premiere for the Yocto Project. It's a premiere for me as I've never done something like this before except in test runs. And for the formalities, let me do the small Yocto project intro, which is welcome to the live coding with Yocto project streaming series. Here we're focusing on the most important concepts for Linux development using the Yocto project. You don't need to have any prior experience with the Yocto project to follow along with this tutorial, but you will find it helpful to have some prior experience working with Linux systems and having a basic understanding of how software is configured and built under Linux. Well, nothing to add there, so let's jump right straight in. Here is my terminal. I hope you can actually see it. If not, I'm checking back into the chat and complain loud and complain quickly, please, so we can actually take care and fix things. But I think the font is big enough so you can actually read it without putting on your remote glasses and everything. So, what are we going to do right now? The first thing you always have to do when doing something with the Yocto project is you get a fresh clone of Pocky. Pocky is the reference distribution of the Open Embedded Build system plus BitBake plus some additional goodies that our Yocto internal gods nicknamed as Richard Purdy and Ross Burton and Armin Custer truthfully and perfectly provide for us, so we can just start and do nice things. I'm just seeing that my build machine takes 1 or 2 seconds more to sort out everything, which is why we're going to jump over, and you're seeing totally pointless data. Hooray for a first go, which is not supposed to go like that. So I'm gonna talk a little more at the moment. Yeah, what are we going to do? We are going to clone Pocky, the reference distribution. We're gonna set up a build based on it. We're gonna run the build, and we're gonna boot into whatever we will have built after a couple of minutes to actually prove that we have really built a full bootable and working Linux system. And if time permits, and if the demo gods do as we want them to, then we can do some minor modifications, like adding a package, like building another image, like showing off what some caches are and everything. Okay, so my build machine tells me that it's ready by now, so here we go. The canonical way to clone Pocky is from the official Yocto project Git server, which can be found at git/get.yoctoproject.org/pocky.git. And here we go, cloning into Pocky. This will get us the master branch of Pocky, which is where all the fun, magic, and also development happens. Especially the latter means that now and then funny things can happen. Funny things in terms of it might do things that are unexpected, expected, or at least not very reproducible sometimes. So the next thing after the clone will be to get the latest release, which is 2.6.2 right now. Just waiting for the clone to finish. I actually wanted to prepare a quick peek at the Yocto website right now. Let me try and do that. Here it is, hopefully. So you can actually see what we are doing. Docs, learn. Here's a lot of documentation on the Yocto project, and here it is, the Yocto project quick start. This is what we're going to actually do live and real. And if you ever want to or need to reproduce, which I totally hope, of course, that you will do, as you have been absolutely sucked into the Yocto project and its fascinating possibilities after my small show, then here's where to start. Okay, I think my clone is finished. So here we go, back to the terminal. We have cloned into Pocky, and we will have a small look at Git. These are all the released tags, and just as I mentioned, we will check out Yocto 262. Okay, and that's it. Now we're on the latest stable version of Pocky that has been released so far, and to actually build it now, we need to source the environment scripts that come along with Pocky. As you can see, I've stepped out of the Pocky directory into the upper level, which means that our build environment to be will be set up there. This means we don't affect or influence whatever is in the Pocky directory, which is a really good thing, because if we would be staying on upstream, or if we had to switch between versions, or if we need to pull in updates, we can do that in Pocky and not lose or modify our valued work. So here we go. And it already says there, you can now run bitbake. What happened now? This did a lot of magic. Basically, it created the configuration for us in two ways. Once, what gets included in the whole build mechanism. These are all the layers that that come with Pocky. We will talk about that probably in a later stream. If we have enough time, we can do it after the build, also in a little bit of an overview, but we will see what happens. And it creates a local configuration, which is the build that we are going to carry out. And let me check if my build server is actually ready to go, because we're going to need a lot of performance for this. Anybody who ever installed Gentoo, or even harder, did a Linux from scratch will know what I'm talking about. We are really building from scratch a whole Linux distribution. So so we can see what's really going on, how long it will take. Core image minimal. Core image minimal, as pointed out in the quick start, is basically the blinky LED of any Yocto project or open embedded based project. It's like, go build something that can boot. If it boots, the LED blinks. That's it. So let's try and see what happens. We kicked off bitbake core image minimal. You can see already in the syntax bitbake and a target after it, which is usually a recipe or an image, tells bitbake to start or start running and bake in a more or less literal way that whatever we told it to bake. This build machine is obviously a bit loaded at the moment, so you can see that parsing all of the data that already came with Pocky takes the better part of a minute, but that's okay. It can take even considerably longer if you're pulling in a lot of additional stuff, or if you're God beware doing that in a virtual machine. But I will strike that topic probably more than once in the next couple of minutes. Do not ever, unless you are forced to, try to do this in a virtual machine. You will suffer great pain and waste lots of time for totally no good reason. Okay, and now things are really starting to go nuts. A lot of things are happening, and you can see that basically for whatever thing you could ever imagine to go into a Linux distribution, or that is needed to go into a Linux distribution, uh, it does something. In the most cases, you can see do package, do set scene, which means it just takes those things and packages them. So I just promised you that we are building a complete Linux distribution. This is an awful word. From scratch, and now you don't see any compilers running. You're just seeing packages. This is because I cheated a little tiny bit, and I already did the compilation stage yesterday evening because it took about 3.5 hours, and it's actually quite boring to watch. So I thought you would rather enjoy to just see what happens, and we will do one or two recipes in great detail and see what really happens when you are building from scratch. But there's little fun in watching like 20 minutes of progress bar just telling you that it's compiling GCC right now, which is another reason why you should not do this in VMs. Do it in containers. Containers are cool. Okay, and now you see everything is finished. Pocky claims, or BitBay claims, to have produced a complete Linux image for us, including the kernel. And so let's have a small look what it actually did. I'm gonna go into build, temp, deploy images, and QEMU x86. Why is that? A build means this is our build directory where we are starting to do funny things. Next thing, temp. Temp means anything that is temporary, that is not of any real value. It can be recreated any point in time that you desire, so it can be deleted any point in time. You're not gonna lose your work in the inner meaning of the word if you delete temp. It just takes you some more compilation time to recreate it, but it's not gone. Deploy. Deploy is whatever falls out of the whole build process in the end. These are things that you can actually take and use for some purpose that you desire. And images, yeah, well, we wanted to create an image that we can run in boot. QEMU x86, that's the default architecture. If you're doing a build, it should also be mentioned in the quick start manual. So that's why we're going there. Let's have a quick peek. Okay, that's a little bit too big of a font. I'm gonna scroll down just for a couple of seconds so you can actually read what's going on. I'll promise I'll make it larger right away. Just two or three small things to point out. You can see core image minimal QEMU x86, huge timestamp .rootfs.ext4 at 11 megs. This is the root file system, the complete userland, and you can see you should be able to see, I'm gonna scroll, no, you can see the big zip image with its 7 megs. You can see the modules with its also about 7 megs, and you can see a manifest file. We're gonna check into the manifest file in a couple of seconds again. So zoom in again. Hope that's fine for you to read. What does the quick start say that we can do with that image right now? You can boot it. And how do we boot a QEMU image? Yeah, well, we're gonna run QEMU. For that, we step back into the build environment because, as you can see, Pocky brings along a run QEMU script, which is super handy if you want to give those things a nice quick test. Run QEMU, QEMU x86, and we are connected to a cloud instance over SSH on Amazon's AC Square. So, well, there won't be a screen for us. That's why we're gonna need no graphic. Here we go. And you can see the kernel is booting, running off. And after a couple of moments, we're gonna step into our brand new, freshly built Linux userland. Let's just have a small peek what's going on there. Yeah, root file system with about 10 megabytes. We're running Linux QEMU x86, release 4.18.27 Yocto standard, as provided by our ever awesome Bruce Ashfield, who is, I think, also listening. So if you see things that you don't like, go poke him directly. And so, what can we do there? Actually, not that much. It's just a really bare bones userland that we have just booted up in QEMU. So I'm gonna stop that again and see what more we can do. I think this is a good occasion to peek into the chat, where some guy named Yak 2016-2 asks for an SD or SSD image. Yeah, that's actually not that big of a problem. You just do not build for QEMU x86. You basically build for a generic x86 machine. Like I think it's let's have a peek into local.conf. That's the easiest. Conf local.conf. There's a couple of examples. It supports QEMU ARM, QEMU MIPS, QEMU PPC, QEMU x86, and there's also generic x86 and generic x86 64 bits. And I'm not completely sure what's the default image that falls out if you build for generic x86, but it's not far away from a image you could put onto an SD card or onto an SSD. If somebody from the class, the usual folks from our IRC could step up and give you some pointers, that would be nice. If not, then usually we can help you quite nicely at hash Yocto on Freenode IRC. They're the folks from especially Intel who are actually working on x86 should be able to answer that in about no time. I hope so. Okay, and here's already somebody who seems to know what I'm talking about. I mentioned earlier that I cheated a little bit, and I'm gonna show you where. This is here. In an off-screen terminal that you could not see in the stream, I uncommented this variable dldir and set it to a directory that I have prepared with all the downloads of the sources that we need for the demo image. And I also uncommented this state dir also to a directory that I, as pointed out, prepared yesterday evening. Okay, so this basically is what we really wanted to show you. It's how you take the sources and produce a full-blown Linux image, which is not doing that much, but hey, it's a real image. So what we could do now to show off is, for example, add something into the image to make it more useful. What is usually considered very, very useful, it's a calculator, because as we all know, every engineer loves a calculator. A classic calculator for the command line is called BC, and if you want to add something right offhand into your image, you're gonna do it like that. Let me point out quickly that this is the ad hoc way. This means it's it is reproducible, but with additional work. You have to write it down into the local.conf file every time you set up a new build, and in one of the later streams we will certainly show how to create a meta layer and put your own images there. And if we are continuing at that pace, we might even do it later in like 10 or 15 minutes. And if you have poured everything into your own layer, then this is where you keep your stuff, and this is where what you put into your source code revision system, and that you keep, so you can reproduce everything whenever you want to, and you can just set the machine and the image in your local.conf, and that's it. But I'm digressing. We're gonna add PC, and I'm gonna look up the correct variable name. It's core image extra install. The core images that come with the Yocto project support this variable to contain things that you want to go into the image. And I happen to know that BC is already there, and I want BC. I love BC, at least for demonstration purposes. So I put BC into the variable. That means, hey, install BC. And now this is one of the key concepts that you have to understand if working with a build system like that. You do not build BC, because if you build BC, well, then you have built BC. It gets packaged and then nothing. You rebuild your image. The variable basically tells the image that this is a new dependency that needs to be built before the image and then gets pulled into it. So again, we're gonna build core image minimal. Core image minimal. And I think this is gonna take a little longer this time, because I did not prepare BC. So you can actually see what really happens when something is downloaded and installed. While this is running, I'm gonna have a small peek into the chat. What's going on? Oh, okay, we're just talking about x86 and WIC. Richard is the man to tell you that. If you ever work on the Yocto project and you're doing awesome things, then do not forget to tip Richard off. He's the man that makes everything work, at least in public. I know there's a lot of very very helpful minions also involved, but he's basically the forefront runner, at least at the moment. So it is still already building the image. I talked so much about Richard right now, so I'm super confused. Did it build PC? I hope so. Let's boot up the image again and hope that PC is there. If not, we will show some Yocto project debugging. And let me just mute myself for a moment. I've got important things to do. So I'm back. People who know what I'm doing here That means people who have endured myself through the testing stage know that I'm actually streaming from a pub at my own time because I don't have a nice place at the office and nobody's gonna bring me drinks there. So I go to a pub. And this is also the concept of this stream, like meeting in a pub with a friend or a coworker of yours and saying, hey, do you know about this Yocto project thing? Can you tell me something? Can you show me something? And, well, yes, okay, I can. And here is BC. Great, that's what we expected. Syntax error, of course, 20. Great, power off. We don't have minions, we have contributors and maintainers. What does the Oxford Dictionary say on that difference? Can anybody please check? I consider myself a minion. I'm not contributing and not maintaining. I'm just sitting in pubs and um, telling random folks on the internet random things about cool stuff. Croft and don't give all my secrets away, okay? Hey, I have proof. I'm drinking water. Really, this is water right now. So, this was um, this was the we have to do program. Is there anybody on the IRC or the stream chat that wants me to show something specific to demonstrate or comment on questions? If not, I'm gonna probably digress a bit into what the manifest tells you, and maybe we'll even start in creating a layer. Anybody? Hands up. Please comment on what you want to do. In the meanwhile, I'm gonna show you the manifest. The manifest is the one thing that you want to give your project lead, who in turn will give it to his manager and saying, hey, if we're gonna use this, we can absolutely be sure that no code that we do not know about its licensing and its costs is going into our images. And if we don't ship any license problematic things, this is a good thing and we can sell our stuff and still sleep tight. How does this happen? We're gonna look into Temp Deploy images QMX86 core image whatever rootfs manifest, and here it goes. It tells us exactly which package went into the image before it got, or when it got pulled into the one blob that you could actually ship. And this is basically the proof for what I told you earlier. This is really bare bones. This is just base files, base password, which is like the the absolutely bare bones directory layout that you need for anything that's even remotely close to a Linux userland to actually work. It's BC because I wanted it. It's BusyBox to provide for a lot of the command line utilities. It's some init script minimal functions. It's the kernel. It's the GNU glibc in form of libc i586, some minimal utilities, ncurses, sys5 init, and basically that's about it. There's nothing there, which explains why it is so small. And if we want to really know in more detail, we're gonna go into the licenses, deploy, and there into the core image minimal QMX86 build that we just did a couple of minutes ago. And if we look into what's provided there, then we pick the wrong file, of course. And here it is. This is the complete version and license list of whatever went into that package. Now, please do that with whatever your favorite other distribution is, and be certain that it is correct. This is one of the really strong points if you're in the industry. Can anybody of my chat minions in the background please take note of hopefully finding somebody to do a stream on more details of this? Somebody who really is into license compliance would be cool. I think that's something that's worth showing. Okay. What shall we do now? I'm seeing that somebody asks for porting simple Hello World examples. Python, Go, JavaScript. That's all those languages have quite their specifics because they all have their own package managers, which makes them not exactly pleasant to work with. I'm planning to do a Hello World example for C++, C using CMake for sure. Hopefully the next time or the time after the next time. We will certainly look into doing this. Maybe it won't be me. Maybe we can find somebody who's into Python or Go. I know that at least Paul is working on Go and cursing it constantly in the last couple of days. I could probably do something on JavaScript sometime, some next time. Might somebody please take note of this? Okay, any other urgent questions right now? I don't see anything, and Nicolas is taking note. Great, thanks a lot for this. It's I know it's really an important topic because more and more software also for the embedded space is written in those languages, and it's a good thing. I personally do a lot of JavaScript these days, but it's a little hard to get the twist of building things with Open Embedded using those languages right. So it's certainly worth a full-blown session, which should be properly prepared, and I can't do that right ad hoc now. So still no more requests, which makes it like bingo. What shall we do? What shall we try and display for you? I would give a small peek into the metadata, if that's I think that's a good idea. And then I remember we should have a look into the documentation. Documentation is really a strong point of the Yocto project. Scotty is doing a great job there, and if you ever work on the Yocto project, you will know why you owe him more than just a beer. And I think we should inspect that as the final thing then. Let's take a look into the actual metadata, which is what you will be writing if you're working with this technology, and then into the documentation, which is what you will be reading if you are working with this technology. I think that sums it up pretty nicely. So do I have I do not have Midnight Commander here. I will need Midnight Commander. Get install. You can see I am on EC Square, and MC. Here we go. You can see that inside Pocky there is meta, meta Pocky, meta self-test, meta skeleton, meta Yocto BSP, where of which meta is certainly the one that you will be looking into mostly for examples. And each of those meta prefix directories is a layer. And layers are structured in a way that they contain a directory called conf, which defines at least a layer.conf file. Bad pick, I know. We should look into something easier. Here it is, metaskeleton.conf. That's a more bare bones layer. It contains layer.conf, which contains a lot of magic, which makes things work. Okay. And a couple of directories called recipes-whatever. Recipes-whatever is the way to structure your recipes inside a layer. So we're gonna look some more. Inside recipes-core, for example, here is a busybox, which means that here is a directory that contains a busybox recipe or something related to a busybox recipe. I say related to because you can have many layers all stacking up, and they can interact or modify each other. So just because something is in a busybox recipe here does not mean it's the only busybox recipe, and it almost certainly is not. It is probably an append, just like I told you, that adds something to busybox. I think we should have a small peek. Why do I get nano? This is yeah, just as it says, it's an example. It's a stupid example. Let's get out of here. No, I do not want to. I want to exit. Okay, here we go. So let's look at some real recipes. That's more fun. Recipes core. I think as we've been talking about BC, we should talk a little more about BC. Here is BC. It's in meta recipes extended, which those things after recipes dash are not set in stone. You can basically put there whatever you want as long as it's not containing spaces or umlauts or other stupid things. So here it is. Here's my beer. I'm really running dry because you're such a demanding audience, and I'm gonna feed my own cliche. That's for sure. Cliches are wonderful, especially if you live up to fulfill them. So we gotta look into the BC recipe. BC, here it is. This is basically what you would write down if you add a package into your build. I'm not gonna run down everything today. This is way too much for the remaining time I've envisioned to spend talking to you folks. But a little pointer here and there. It sets a summary in the homepage. Well, that's obvious. It sets a license, which is absolutely essential. And it also, this is more of a surprise for newbies, it also sets a checksum on license files or license mentionings in the sources. And this means that whenever some package gets version bumped and updated in the upstream, and sometimes the license changes, then these license checksums tests will fail and everything will come to a grinding halt, and therefore totally avoid that the license manifest contains things that you do not expect it to contain. So again, this is industrial strength focused. It's not exactly what you probably want if you need to do a one-off board for your personal heating control room or webcam or just for fun thing. It's in that case, if you're up for tinkering, you will probably could do it that way if you're up for learning. But if you're up for the result, it's probably easier to just run a run-of-the-mill distribution like Debian, Ubuntu, whatever floats your boat, whatever your likings are. If this is this is going really strong if you need to do things. This time you need to get your licensing straight. If you need to do it in a year, and you still need to get your licensing straight. And I think you get the meaning. If you're doing this for a living and you need to reproduce it for extended periods of time, you need to support it for extended periods of time. And if after a year somebody says, "Wow, this breaks," you need to reproduce it. You need to look into it. So what else is there? There is a variable called depends, which means what needs to be there in order to actually build that recipe. In this case, this is flex, to be run on the host, as denoted by the native extension. There is a source URI, which means go there to find the upstream sources. Some small patches. This is also a thing that often happens if you are dealing with sources that are not totally cross-compile aware, because you will be cross-compiling a real lot if you're using Open Embedded or the Yocto project. Then there's some inherits, namely autotools, text info, update alternatives. The only interesting thing there actually is autotools, because this tells your recipe that the sources are autotoolized. And if they're autotoolized, then the whole shebang from .configure, make, install, whatever, just should work out of the box. Gonna step down a little more. Nothing highly spectacular to see here. So I think that concludes our little digression into what is the in the layer. And for the last thing I announced, let's look into the documentation. Let me check where I get. This is really weird. Why does my broadcast thing keep on forgetting where my browser is? Hopefully, here we go. This is the quick build, and I gotta jump and find two specific things. For once, this is the project development manual. This is basically where all of the core information is summed up and provided. It's long. It's sometimes a bit overly exhaustive, but it's really the thing to go hunting if you are if you need information. It outlines the real common tasks: creating the layers, customizing images, and especially writing a new recipe, which is, as you can already see by the number of subtopics, it's just way too much to just do it in like 5 minutes, or what we're going to to spend on that specific topic today. You're gonna add a new machine, and look it up for yourself. I think it's not really worth going over every topic that's mentioned in there. But let me repeat, the really important things are creating and understanding layers, customizing images, writing new recipes. Those are the things that you will do like 90% of your time when you're actively working on creating a Linux image. Then the last piece of development I want to show is the Yocto Project Reference Manual. Why exactly that, when there are so many pieces of information? Especially because, if I'm not totally mistaken, yeah, here it is. It contains documentation on all the classes that come, basically batteries included, just like auto tools that we have just used. Here is the complete documentation on what this actually means. It brings a do compile stage, it brings a do install stage, it brings do configure, all those things that auto tools are related to. It contains a lot of documentation on all the internal stages and tasks, which we should really work through in another stream too. And this is the one I really wanted to show you, the variables glossary. If you're working with the Yocto project, you gotta see a lot of variables that are set to funny things back and forth and everything, and often you don't know what they actually mean. And this is where you gonna see and check what their meaning is, what the magic behind them is meant to do. So this is, if you're getting started, bookmark this. Okay, just as we have talked about the variables, let me see show you how those variables actually can be inspected. I think this is the last thing I should do right now. Bitbake minus e, and your recipe afterwards tells Bitbake to not build that. It tells Bitbake to just evaluate it and then tell you whatever happens. And parsing takes quite some time on the demo instance, so I'm not gonna show you all the big shebang of data flowing through, and directly add the pipe through less. And here it goes. So this is actually what happens whenever Bitbake runs and creates data. And to inspect things, you better search. And as we have already covered the meaning of the depends variable, we're gonna check what's in there. And you can see that in this case, for example, depends is finally set to QEMU wrapper cross, stepmod wrapper cross local dev native, and that's it. That's what the core image minimal really needs to be built and in place before it's able to be put into its final form. Another thing that you also inspect quite often is image install. And the one thing I want to show you right now there is that bitbake minus e not only tells you what is in those variables, it also tells you how it went into those variables. And in this case, you can see that in the second or third, given the large font here, the core image minimal recipe sets package group core, and the variable that I set earlier to BC has its contents, and that is expanded then into core package group core boot and BC, and that's why all those things end up in the image. So bitbake minus e is a really valuable tool to inspect what is going on in your build, but always pipe it through some means of paging or grabbing. You're just gonna lose your mind if you do not. So I will have a last peek into the chat right now. My browser got lost again. Well, that's so stupid. Well, something went really wrong. I'm gonna look it up in the recording, and I actually did not switch back to the terminal, which is probably super stupid. So last peek into whatever I just told you about image install, the whole evaluation shebang. So the pub around me is starting to prepare for dinner time. For me, it's time to say thank you. There's nothing highly surprising in the chat anymore. I seriously need to find out why the Twitch streaming tool loses the focus on my browser each and every time I switch back and forth. That's really annoying. So I think that's it for today. Thanks everybody for watching. Um, if you have ideas and requests, as already pointed out, just shoot them into the chat here. We will try to take note of it. Shoot them into IRC about every time during European and US EN daytimes. Some competent folks should be around, and if not, there is at least somebody around who knows whom to ask. Well, that's usually me then. Um, well, I think that's it. Don't forget to check back the next time. I think it's 2 weeks from now. Don't forget to join the IRC. Don't forget to just go out, try and tinker with the Yocto project and make awesome things happen. Well, thanks a lot and bye.